Hi everyone and welcome back to my channel A in Economist. So today we are going to start off with econometrics. This is going to be our first lecture, that is an introductory session on econometrics where I'll focus on two topics. Firstly, what is econometrics? So firstly, I'll give you an example and try to explain how econometricians think about this discipline and how they approach in problem solving. So I'll approach that. And the second thing that I'll cover is what are econometric models and how we construct econometric models and how they differ from the usual statistical models that we use so far, right? So let us start with the topic today. So firstly, for example, think that you are an econometrician and your job is to find out the relationship. Suppose the problem in your hand is to find out the relationship between two economic variables. What are they? Relationship between consumption. Consumption is one of the most important economic variables that we deal with. First is consumption and the second is income. Second is income. Suppose I denote it by Y. So as an econometrician, you start with an econometrician and you have to find out the relationship. You want to know, you want to understand the relationship between two economic variables. First is consumption, which is denoted as C. Suppose I call it C. And the second is income, that is Y. Now your job is to find this relationship. Now, what are the steps that you need to follow as an econometrician to land up to the exact relationship and also to validate this relationship? Let's look at the steps. Firstly, what econometricians do is that you have to rely on some economic theory. Please understand this step because this is the most distinguishable step that econometricians use that statisticians don't usually use. So as an econometrician, what you have to do, the approach that is being taken is, firstly, you have to start with some economic theory that is already being propounded by someone. So if you are an economics student, undergrad or postgrad student, then you will know that we study different consumption theories, right? There are relative income hypothesis, there is permanent income hypothesis, there is life cycle hypothesis, and so many more hypotheses given by different, you know, economists at different times. So we study all of them in our undergraduate economics honors course. So for our purposes, for simplicity, let us suppose we go with the Keynesian consumption function and Keynesian consumption theory. For our purposes, you can, consider any of the theories, but just for simplicity of our explanation, I am using here Keynesian consumption function. Keynesian consumption function, right? Keynesian consumption function. So what Keynes has told is that theoretically, we are not yet started with any equations or not. So Keynes has propounded that consumption is only a function of income. If you know the Keynesian theory, you will know what Keynes has told is that consumption as a variable is dependent only on your income. And not only that, as your income will rise, as your income will go up, intuitively also you understand that your consumption will go up, but your increase in consumption will be lesser than the increase in income, right? Your increase in the consumption due to increase in income will be lesser, right? And that is been captured by something called the marginal propensity to consume, MPC, marginal propensity to consume, which should be in between 0 and 1. So this is something that Keynes has told, right? So what econometricians do? So they know this theoretically. Theoretically, this has been propounded by Keynes, so this is known to us. So they will rely on this economic theory, for example, and then what they do, they will come up with some equations. They want to model this relationship between C and Y using this economic theory. So they will say that, okay, So there is a linear relationship. Suppose we consider there is a linear relationship. So C can be written in a very simplistic linear model form, A plus BY. Suppose the most simple form, that consumption is a function of only income, right? Income is the only exogenous variable here. And not only that, it is a linear equation because see, parameters are linear and the variables are also linear. So everything is linear. Not only that, what is MPC here? MPC is B. This variable B represents MPC, right? So B is nothing but DCDY. DCDY, and according to Keynes, this B should strictly lie in between 0 and 1. Let me write it down. 0 less than B less than 1, right? So this is all that is known to us before going into any calculation. So what you have done, you have firstly relied on some economic theory, and which has given you the theoretical understanding of the relationship, plausible relationship of consumption and income, that yes, there exists a relationship. Not only that, there exists a linear relationship, and you also know what is the restriction on the parameters, that A can vary freely. There is no restriction on A, that is the intercept parameter is free to vary, but this MPC, that is the slope parameter, has a restriction that it should lie between 0 and 1. So theoretically, this much is known to us, and this will constitute your first step in approaching the problem that you want to find out the relationship between C and Y. Okay. Now let us go to the second step. What is the second step? The second step that econometricians will do is they collect the required data. Collect the required data. Please pardon my handwriting if you find it difficult to read. I hope I am writing it clearly. If you have any difficulty, you can let me know. So the second step that you have to follow is to collect the required data. Now this data set, suppose if you are talking about Indian context, you can find out the household survey data, consumption income survey data from any government sites and all. So many, data sets are freely available as well. So from that, you will find out the consumption data and the income data, and this will form your required data set. Suppose you take out some sample and you collect the required data from them. So this is the data set. So if you are a statistician, you will start with this step. You will firstly collect the data and then you move forward. But as an econometrician, it is mandatory for you to rely on some economic theory, because you are trying to validate economic theories and you are trying to, validate the model or the theoretical understanding that you have. So you have to rely on some theory. This is the, most important step that you follow. Okay, so second step is also done. So you have to collect the required data from some reliable source. And the third step that you have to follow is to use proper econometric or statistical methods. Statistical methods to verify and validate, right? The third important step would be to use certain proper econometric method or statistical method to validate or to verify what you have assumed, right? So you have started with this kind of a relationship, then you have collected the required data to test your, hypothesis or any sort of inferencing method that you use. So third step would be to use proper econometric or statistical methods. Here, firstly, what you have to do, you have to estimate the parameters based on the data. You have to estimate the value of B. So we have to find out B cap basically. And then you have to test the hypothesis that yes, this is less than 1 or not. This lies between 0 and 1 or not. So this is something that you will do, right? So this is the entire thing. These are the entire steps that an econometrician would follow in order to answer this particular question. So what you have to do, your problem is very simple. You are just trying to find out the relationship between two economic variables, right? So I have come up with this example just to let you know the approach, because many students, I see that they are unable to understand what is the difference between econometrics and statistics, because the initial things that we do, We do it also in statistics. So, but there is a very clear distinction. I hope I am able to make you clear on that point. Why it is different? Because we are heavily reliant on some economic theory. That is why it is econometrics. We use statistical methods, statistical techniques. Many of the methods are same. As we go forward in this playlist, you will see many of the techniques are same as we do in statistics. But this heavy reliance on economic theory and our end goal is to validate the economic theory, or to make our understanding stronger of the economic theory, and to verify that yes, what we know is right. That is the main essence of econometrics. I hope this is clear. Now you can put this relationship on a diagram also. So here, if you see on this axis, you have national income, total national income. So here we are talking about some individual people, right? Income of some individual and consumption of some individual, but you can consider it in some macro perspective also. If you consider it macro perspective or in economy wide perspective, then what you see here on this axis, you measure the total national income, which is measured in billion rupees, rupees billion, right? And here you have the consumption, that is the total consumption expenditure economy wide. Now, what you see in this diagram is that if your income, national income grows for 800 billion to 820 billion, so there is a 20 billion rupees increment in your national income, then what do you see? Your consumption has risen, right? This has rose, but this rise is lesser than your income rise. See, here the increment is only $4 billion. So if you find out what will be the MPC, that is DCDY, what will be the MPC? Change in consumption. In the numerator, you have change in consumption. So change will be this much from the initial. And what is the change in income? 820 minus 800. So if you calculate, here you have 4, here you have 20. So 1 by 5, which is 0.2. So which basically satisfies our assumption that it is less than 1. So in the diagram you see here, this relationship is given by this straight line, which has a slope of less than 1, right? If you measure the slope, if you draw a parallel line to this and then measure this degree, this will be less than 45 degrees. If this is an exact relationship 1 to 1, that is, then the line would have been 45-degree line, right? If suppose your income has risen by 20 billion rupees and your consumption has also increased by 20 billion rupees, then this would have been a 45-degree line. I hope you know these things, right? So similar thing. Now, if you have this theoretical understanding and you have already validated this theory, and then you can put it in a diagram and explain it in a lucid manner. So that is the thing that you can do. And this is what is the linear consumption function that we are talking about. And this function is working only because we are taking an algebraic model as of now. We have not introduced any randomness in the model. So we are saying that there is a one-to-one relationship between income and consumption. There is no randomness. But later on, when I'll talk about the econometric modeling, then I'll say that randomness is a very important component that we have not yet introduced in this model. So I'll come to that. Okay. So now when we understood this example, we are in a position to know the definition of econometrics. What is econometrics? If I have to explain simply, it's the art and science of using statistical methods for measurement of economic relations, right? So it is very simple definition that econometrics is the art and science of using statistical methods. So we use statistical methods, but the intention is different. Intention is to measure the economic relationships. I hope this is clear. Okay. Now let's move on. The next thing that we will study is the purpose. There are three basic purposes. Why do we study econometrics? There are only three basic purposes. First is to do the structural analysis. What is structural analysis? Structural analysis is the use of estimated econometric model for quantitative measurement of economic relationships. So if you understand simply, you have this model and with the help of required data, you have estimated this thing, right? So since you have estimated the parameters, you have estimated the this also. So if you vary the value of y, you get the predicted value of c. So this is the estimated model of depending on the Keynesian consumption function. Once you have that, what you can do, you can use this estimated econometric model, right? You can use this estimated econometric model for further quantitative measurements of economic relationships. So this is the first purpose of econometrics. What is the second purpose? Is forecasting. Forecasting means when you are trying to estimate something which is not in your sample. That is the forecasting. Forecasting is the use of estimated economic model to predict quantitative values certain variables outside the sample data actually been observed. So suppose, for example, you have collected the samples for 10 individuals. So you have the data set of income Y1, Y2 up to Y10. So now if you put the value of y's here, suppose this is yi, so you put values of y1, y2 up to y10, you can easily get the C1 estimated value, C2 estimated value, and C10 estimated value. So this is what is the predicted value. These are the predicted value. Now, what if you want to find out the 11th person's for the 11th person? You collect the data for the 11th person, which is not in your sample. Your sample has only 10 members, but for the 11th person, also you can use this model. Now, the value that you will get for C11 cap, this will be the forecasted value. This will be the forecasted value and not the predicted value. So this is the difference between forecast and prediction, right? So forecasting is the use of estimated econometric model to predict quantitative values of certain variables which is outside the sample data actually observed. I hope this is clear. Again, if you have any questions, you can let me know. And the third thing is the policy evaluation. So policy evaluation is the use of this estimated econometric model to choose between alternative policies. So once you have this estimated model, you can, do the cost benefit analysis and see which policy is giving you better results, and you can choose the policies uh, accordingly, right? So these are the three basic, uh, principal purposes, right? Why we study econometry, these are the three basic purposes. We want to do structural analysis. We want to know the relationship among economic variables. We want to do forecasting, and we also want to do policy evaluation, right? Now, everything that I have told you so far can be summarized using this following flowchart. And this is the summary of the econometrics as a subject. If you want to know in one slide, in one page, this is the approach, econometric approach. So this is the same thing as I have told you. Firstly, you have to start with theory. Without theory, there is no econometrics. So start with some theory. This theory will give you some model. Model means nothing but relationship, right? So we started with Keynesian consumption function. We have come to the model that C equals to A plus BY. So this model has come up from the theory, right? So you have obtained some model, and then you have to convert it into econometric model that I'll come in a while when I'll talk about econometric model from the next slide. So I'll say how to convert this algebraic model into econometric model. So this part is done. And then you start with some facts. You have some surveys, government surveys from independent bodies, researchers. So you have some facts. From that, you have to collect the required data, and then you have to refine that data. So you have to do the data cleaning. So you have to basically prepare the data set and omit all the missing values, and you have to handle the data set well. You have to clean the data set and mold it into a usable form. So you are getting the refined data, which can be used for, right? This is also done. And then finally, the third step is to use some statistical theory and use some econometric techniques. And if you have all these three things, one econometric model, one, then you have refined data, and then you have the knowledge of some, econometric technique, then what you can do, you can do the estimation. You can do the estimation of what? Estimation of this econometric model with the refined data using some econometric techniques. And what will be the result? Result will be the purposes will be solved. What are the purposes that I have told you? First is the structural analysis. You can do structural analysis, you can do forecasting, and you can do policy evaluation. So this is everything that you need to know about the approach, how econometricians think, how this discipline was formed, and why it is used for. I hope this is absolutely clear. Now, the final topic that I'll cover is what is econometric modeling. So model is again the relationship. Now this econometric model is different from algebraic model in the sense that econometric models are stochastic in nature. This is very important thing. You have to understand this. Why this is stochastic? Because it includes one or more random variables. Please understand this thing because in every step that I'll cover from the next video will be dependent on that. You have to have a very good knowledge about random variables before taking up econometrics, right? Okay, so in suppose I write something like this, y equals to 2 plus 5x. If I do this, then this will be an algebraic model because why it is algebraic? Because it is only some system of equation. It is only a linear equation and you know the one-to-one relationship between x and y. For every value of x, you have a value of y, which is also known as deterministic model that I'll define later. But in case of econometrics, what happens is that it is a special type of algebraic model. Special type of algebraic model, namely stochastic, which includes one or more random variables. So in this model, if I add something called epsilon, where this epsilon follows some normal distribution, say 0 sigma. So what does this mean? This means that this now becomes a random term. This is a random term or which is a stochastic. Stochastic means random. This can be used alternatively. Random and stochastic are the same thing. So stochastic, if you include one stochastic term here, the entire model becomes random. Entire model becomes random because y is not only a function of x but is also a function of epsilon, right? So this is econometric model and that is the difference between algebra. So from the theory, if you want to model something, whenever you want to model something, you are trying to find out the relationship between variables or relationship among variables, many variables. So this is fine. So basically from the theoretical knowledge, if you have to put something into system of equation, that will be termed as algebraic model. Now, from that algebraic model, if you want to include some random terms, because in real world, nothing is certain, right? Uncertainty is ingrained in every real life scenario. In any problem you take up, some amount of randomness, nothing can be said certainly. And whenever there is uncertainty, there is randomness, you have to include some, to make the model more realistic, you have to include this random term. And I'll be coming to this, why we include random term later on in this slide. Okay. So this leads us to the differentiation of deterministic and stochastic modeling that I have already explained to you. Let me write it down. So deterministic, suppose I call it D. So deterministic means for each value of X, there exists an unique value of Y. And I'm talking about the context when y equals to a function of x. Suppose I call it 2 plus 5x. This is an example of deterministic model. Deterministic and algebraic model is the same. Deterministic means there is a unique relationship, unique value. For each value of x, if you change the value of x, you will have a change in the value of y, and that is very certain. There is no uncertainty associated with this. Now, what about stochastic? Stochastic means y equals to 2 plus 5x plus epsilon, what I have told you earlier, which means that no unique relationship. No unique relationship between x and y. Why this is so? Again, because this is random. You don't know what this term is. If you don't know this, you don't know what is the exact relationship between x and y. So you only know some properties about this random term. Depending on that, you can try to find out what will be this relationship. You can see this diagram also for more clarity. See here, this is the Keynesian consumption function in stochastic form. This is an econometric model. Now it becomes an econometric model since the random term is included in this. Now suppose I call that expectation of this random term is 0 and variance of this random term is say sigma square. And this random term is normal. Following normal distribution, this. Then what do you know? Since C is a function of epsilon, y is, please understand, y is non-stochastic. Here the explanatory variable y. Y is non-stochastic means it is generally some numbers. Income is some numbers. Certain values rupees, 100 rupees, 200 rupees, something, some number. But this epsilon randomness comes only from this term, and this term is not random, right? This term is not random. This term is non-stochastic. So since C is now a function of this epsilon, C is a linear relationship. C has a linear relationship with epsilon. So C is also becomes random. So C will also follow normal, and the mean will be this A plus BY, and the variance will be sigma square, right? Epsilon, we have assumed this property of epsilon, random term, we will assume some properties. Depending on that, we will see our dependent variable C will also have certain properties depending on this random part. And this, if you have this relationship, then this is the consumption function. This is the consumption function that will look like. This is the function C. It is a normal curve with average value A plus BY. This is the average value, and the variance has corresponding variance is sigma square. I hope this is clear. But if we have considered deterministic, if this is deterministic relationship, then the diagram will be as we have seen earlier, that there will be a one-to-one relationship for every value of y. Suppose I call it y1, there is a particular value of c1. For every value of y2, there is a particular value of c2, and the slope has to be less than 45 degrees, less than 1 basically. Angle has to be less than 45 degrees. I hope this distinction is clear. What is the distinction between deterministic and stochastic modeling? It is very evident from these two diagrams that when you allow stochastic, modeling, then you will have a distribution. The dependent variable will have a distribution like this. But when you allow deterministic modeling, you will have a one-to-one relationship, which will be something like this. So as I have written here, the stochastic disturbance terms are unobservable random variables with certain assumed properties such as mean, variances, and covariances. So if you have seen my time series playlist, I have explained in details what is these properties of random terms. So you can check that out as well. I'll give the link in the description. So here also I have assumed that this random term is following the properties that mean is zero, variance is sigma square, and that has given us this property of dependent variable, that C is following normal with mean A plus BY and variance is sigma square. Right? This is done. The final two things, the components of econometric modeling. Component means, see, this is the y equals to 2 plus 5x plus epsilon. This is the model you have. So what are the three components that you have in the model? First, you have y, second, you have x, and third, you have this. So this is what are the different components of econometric model. Now, the endogenous variable is y. Y is the endogenous variable. Why it is so? Values. Endogenous variable means values are determined from within the model. Endogenous means endo. Endo means inside or from within, right? The values of the variables which are determined from within the model is called the endogenous variable. So in our case, y is the endogenous variable here, because the model is formed just to determine the value of y, or to estimate the value of y, to find out the predicted value or the forecasted value of y, right? So our main aim is to find out the endogenous value of the endogenous variable. So this is one of the components of econometric model. And then you have exogenous variable. Exogenous means the policy variables which are already given to you, which are originated from some separate systems, which are given. For example, in Keynesian consumption function, the income data, income is already given to you. They are already determined. They are the policy variables. They are given to us. So we are not, trying to find out what will be those values. They are the collected. They will be inside the collected data. So exogenous variables is values are determined. Values are determined from outside the model. Values are determined from outside the model. It is also called policy variable. So you can manipulate, basically policy variable means you can basically manipulate these variables and get different results for different points. So this is policy variable, which is historically given, and which is determined from some separate mechanism. Separate mechanism. I hope you understand, right? So this is done. Endogenous variable is done, exogenous variable is done, and the most important is the stochastic disturbance term. It is, let me change the color once. It is the random terms which are added, random term which are added to all equations in the model except identities and equilibrium conditions. Except identities and equilibrium conditions. So these are the definitions. Stochastic disturbance term is the random term which are added to all equations in the model except identities and equilibrium conditions. So these are the components of econometric model. And the final thing that I'll cover in this video and then I'll stop is why do we include this random term? What is the importance? So there are 4 different reasons for that. Stochastic disturbance terms in accounts for the omitted variables which are not so important. So if you talk about Keynesian consumption function like this, so here we have said that consumption is only dependent on income. Income is the only explanatory variable here. But what if I say that consumption is also a function of taste and preference of the consumer? What if I say consumption also depends on the price of the good? What if I say consumption also depends on the innovation of new products? Right? So there are multiple different factors that we have not included in our model, right? Multiple factors. Income is not the only factor that influences consumption. Suppose season, even season, winter or summer, that also, makes a difference in your consumption pattern, right? So these are the omitted variables that we thought are not so important or which are not given in the model, which is specified by Keynes. So we have just simply omitted them, but that will not do. So in order to take into account those omitted variables, we have to include this random term, right? So this random term will take into account all these eliminated variables which we thought are not very important. Second point is misspecifications of a particular functional form. Suppose this is not a linear relationship. Suppose the relationship should be like this: by plus cy square plus dy cube. So suppose this should be the proper functional form, but since we have followed a particular economic model, we have taken this to be a simple linear model. So in order to account for this misspecification, misspecification, that is, omission of variables or inclusion of irrelevant variables, we have to again include this epsilon term. Thirdly, inaccuracy in the measurement. Suppose we have n equals to 10 number of people in the sample, but for the n equals to 8th person, 9th person and 10th person, the income data is not available to us. And for that, what do? You are taking a proxy variable. Suppose you call it y8 plus some epsilon I or epsilon A, something. So this y8, this y9 and this y10 data is not available to you. Actual data is not available to you. So you are taking some erroneous variables, some proxy variables. This is also a separate chapter that I'll cover. So this errors in measurement, this inaccuracies and errors due to lack of the reliable data can also appear. And that can also be accounted with this random term which is included. And last and final thing is the basic randomness behavior, that consumption in itself is a very random term. Consumption in this month will be not the same with the consumption in the next month, or it is not same with the previous month, right? So consumption and income as economic variables are random in nature basically. So this, to capture this basic nature of randomness, you have to include this stochastic term. I hope these are the 4 different reasons, broad reasons that you have to understand. And that is all. I know this video is a little longer, but I wanted to cover everything introductory about econometrics so that in the next video I can straight away go into the classical linear regression model. And thank you so much for joining in. If you find this video helpful, please give me a thumbs up and do subscribe to my channel, A in Economist, so that I keep making some such useful videos for you. And thank you so much for joining in, and let's meet you in the next lecture. Thank you.